Hi everyone, my name is Manjesh D. My teammate is Rahul R. I am currently pursuing my Masters of Computer Application in Chanukya University. I would like to present my research paper Detection of Cancer in Lung with KNN classification. The paper tells us the paper detection of the cancer lung with KNN classification using genetic algorithm presents a method for early lung cancer detection using CT images by integrated K nearest neighbor classification with genetic algorithm optimization. Initially CT images undergo process failure extraction using Corber filters which are effective for the structure analysis. These extraction feature are the classified using KNN algorithm, where GA applied to optimize the section of the K samples sets and the GA operations such as sections, crossover, and mutation help identity the most accuracy implemented in MATLAB. The system achieved up to 90% classification accuracy with reduced false positive and extension time, demonstrating the GA ethanized KNN model is effective for reliable and effective early detection of lung cancer. This is my PPT predicting lung cancer with K nearest neighbors. A combination approach. Backgrounds. Lung cancer can be classified into two main types: non small cell lung cancer and small cell lung cancer. The organ of the lung cancer like to various factors, including smoking, exposure, or metals, organic chemicals, radiation, and air pollution. Lung cancer poses significant economic and social straining health care systems and leading to productivity losses. Introduction. Lung cancer is one of the most important cancer related diseases worldwide. It is one of the leading causes of cancer death globally. Early detection and prediction of lung cancer can significantly improve survival rates. This is a critical need as lung cancer is often recognized at later stage when the disease is more advanced and treatment options are more limited. The study aims to develop a prediction systems for lung cancer using the K nearest neighbors algorithm. KNN is one of the most widely used and effective machine learning algorithm for classification tasks, addressing the need for every detection in combating one of the leading cause of cancer related mortality worldwide is the primary motivation for the research. Objectives: developing a prediction system for lung cancer using the K nearest neighbors algorithm, address the critical need for early detection in combating one of the leading causes of the cancer related mortality. Methodologically, development, evaluation, business understanding, data preparation, modeling, six phases of the methodology. Cancer detection images. You can see optimization KNN for lung cancer detection. The steady utilization of the Comparative Dataset, 10,000 patients record in encompassing medical X-ray and radiography features, ensuring a robot training and process of the KNN model, processing and normalization. The researchers employed data processing technologies such as implementation, and future normalization to ensure the data was clean and optimized for the KNN algorithm. Optimization strategies. The study explored various optimization techniques, including parameters turning and feature engineering to enhance the performance of the KNN modeling. Key finds. Point number one, accurate lung cancer reduction. The optimized KNN model achieved an accuracy of 95% in preceding the presence of the absence of lung cancer on the held out testing set. This high level of accuracy demonstrated the effectiveness of the KNN algorithm in accurately identification lung cancer causes based on the patient data. Point number two, importance of the optimal K parameter. The researchers found the value of the K parameter in the KNN algorithm had a significant impact on models' performance. Through experimental, the optimal value K was determined to be 7, which resulted in the highest accuracy on the set. Robustness of the prediction system. The KNN based prediction system exhibit robust performance, maintaining high accuracy across different substance of the patient data. It suggests the model can reliability lung cancer regarding the variant patient's character distribution. Key findings. Point number 4. Potentially for early detection. The high accuracy of KNN modeling in preceding lung cancer indicates its potential for every detection of the disease. Early detection is crucial for improving treatment outcomes and reducing lung cancer related mortality. Clinically implementation. The finding of this study highlights the promise of integrating machine learning techniques such as KNN algorithm into clinical practice for lung cancer diagnosis and management. The developed prediction system could serve a variable detection support tool for healthcare professionals, aiding in the early identification of individuals at the risk of lung cancer. Challenges in lung cancer detection. Early detection is key to surviving lung cancer, but it's a silent killer that often hides in a blind sight. Currently, screening methods are imperfect, leading the delayed diagnosis and limited treatment option. Invisely diagnosis tests carry risk and are often revised for the high susceptible cases, future delaying detection. Lung cancer poses a significant economic and social burden, undergoes the need for the effective detection methods. Accurate diagnosis and treatment rely on the understanding complementary cancer subtypes. One more topic. Significance and implication. The study contributes the ongoing integration of machine learning into medical diagnosis, particularly in the realm of the cancer prediction. The one more point. The findings highlights the utility of KNN in accuracy production lung cancer offering processing avenue for the enhancing early detection strategies. The incorporation of machine learning techniques can facilitate early detection and promote innovation. One more topic. Cross validation. Cross validation is a statistical method used to estimate the skill of machine learning models. It is primarily used to access the generalized of the model to an independent dataset. The process involves a dataset into complementary subsets programming for the training and validation on different subsets and averaging the results to mitigate overfitting. Steps in cross validation. Point number one, divide the dataset. Split the dataset into k smaller sets or floods. Point number two, train a validate for each unique flood. Train the model on K1 floods. Validate the model on the remaining single flood. Repeat process. Repeat process is above the process of the each of the K floods. Why we need this matrix in cross validation? Accuracy. In cross validation, accuracy helps us evaluate the model's overall perform on unseen data. It gives an idea of how the model is generalization to new data. Precision. In cross validation, precision helps to identify models that are prone false positives. This is purely because of positive can lead into incorrect decision, especially in critical applications like medical diagnosis or fraud detection. Recall. In cross validation, recall helps to identify model that one false negatives. This is important because of negatives can also lead the incorrect decision, especially in the application like fraud detection or disease diagnosis. F1 score. In cross validation, the F1 score provides a balanced measure of the precision and recall. This helps to identify models that achieve a good balance between minimizing false positive and false negative. Advantage of cross validation prevents overfitting and ensure the model works well on new data. Provides an accurate estimate of the model's performance. Helps find the best hyperparameters for the models. Increases confidence in the models. Reduce the risk based results. Implementation. Hyperparametric learning. Use grid search on random search to find the optimization hyper, hyperparametric for the model by parallelly training and evaluation it on the validation set. Cross validation. Split the data into flood train model on flood and evaluate it on the remaining flood, prevent overfitting and estimate generalization performance. Implementation. Fitting missing value. Use strategies such as mean or implementation using model. My teammate Rahul will take over. Thank you.
Thank you, Manjesh. Hi, everyone. My name is Rahul. This is my code. Uh, I improved for required the libraries and then import of dataset. This is the dataset, the top of the dataset. There is a 309 columns, 16 rows. It describes the information about about dataset. Then we describe the static of mean, gender, mode, max, min, etc. and the different types of lung cancers and age, the smoking, yellow fingers and anxieties and allergies, wheezing, alcohol consuming, coughing, the gender male and gender female, in male 142, female 134, the name of count data types. The lung cancers replace the genders. Male it is 0, female it is 1. The the lung cancer value of count lung cancer S. It is 238, no 38. The name of count data types. And lung cancers, replace the lung cancers. No, it is 0. Yes, it is 1. In place the true. Lung cancer head, the gender, smokings. It shows the graph data analysis, exploring the data analysis. And histogram shows the different age and smoking, yellow fingers and wheezing, alcohol consuming. Histogram, it shows the histograms of alcohol consuming, coughing, and lung cancers columns in genders and age. It shows the lung cancers, the different lung cancers is showing the in the histogram. And uh, second one, count flat. It shows the male difference between genders, male and females. Male, it shows the red color, and female, it shows the blue color. uh, the various difference between the smoking and the male and females. Next, in smoking male, it is showing the 0 and 1 female. Uh, and, and then yellow fingers, you can see in the graph. It shows the male females difference between anxieties and zeros. You can see the difference between. And lung cancers columns, the fact titles, kind value of counts, genders, pie, it shows the pie chart. 51% of male, 48% of female. Uh, smoking, smoking 54%, and 45% it shows the female. Then male, it shows the 57%, 42% male. And anxiety is female, both are same. It's showing the 50% and 49%. And then, uh, allergies for 54% of female and 45% of male. Wheezing problems 54%. It shows the 45% of alcohol consuming, 55%. Coughing 57% is the female, 42% of male. And chest pain 55% 0.8, 42% 0.2. Lung cancers and flat figures. Count flat, count flat, it shows the lung cancers. Red color is 0 and blue is 1. Male and female, difference between male and female, the gender, it shows the uh, count flat. And cancers are not cancer. The cancers are 0. uh, Not cancer, it is 1. It coughing, difference between it showing the difference between. And yellow fingers and cancers and shortness of breath, finger, uh, sound flat. It's showing the difference between what is the lung cancer and show in sound flat. And uh, the heat map, it shows the age and smoking, anxieties, and difference between age. And you can see in the map alcohol consuming and coughing, shortness of breath and chest pain, lung cancers, different. It shows the lung cancers. And um, then it is lung, lung the presence of uh, between the lung cancers, and identify the columns. And then we got the accuracy of min and max within the F1 score and F confusion of matrix. Min max CV accuracy 885695006747. It shows robust CV current accuracy 0.89095816. Then min max scaling accuracy is the 89156265060024. FN scores 9387555102048. It shows the robust scaling accuracy in F1 0.867469. Uh, then evaluating the third flow, crossing the validation and best hyperparameters and matrix and including neighbor 7 weight, distance, and confusing matrix 1 and 159 classification of report present special and recall F1 score support. No, it is 0.50. Yes, it is 0.98. Evaluating the five folder cross of validation, best hyperparameters and matrix and weight, distance. Thank you.